Hey guys, this is going to be the first of a series I'm going to have about 3D printers and 3D printing. So actually, you commonly hear the term 3D printing, but it's really referred to as additive manufacturing. So additive by like adding. You are adding layers on top of other layers. All right, so imagine if you had like a bunch of pieces of paper and you just kept cutting like a little bit in every time you'd make like a slight angle. It's kind of like that. It's like laying paper down to make a shape. What you're seeing right here is this is a picture of a 3D printer. Now there's a lot of different kinds of 3D printers. For instance, there are ones that use like liquid resin and a laser, and they laser down, and the UV laser hardens the resin, and it just moves up the water slowly, and then as it's hardening, the shape is pretty cool. The kind that we are going to use for my class is actually going to be like one of these. This is kind of it uses this plastic filament here. It's kind of like a plastic string that goes up through in here, and it comes through an extruder. Now this extruder is a little motor that can move this wire back and forth, and then it goes into this hot end. And imagine this is like the end of the tip of a glue stick, right? It's really hot. You don't want to touch it; it'll burn you. And it extrudes the melted plastic in one layer at a time and slowly builds it up. Now, there's a few different axes here, and different 3D printers are labeled differently, but generally when I look at one of these, I just do it like a graph. I make this my X and Y, or my X axis, so the left and right. The back and forth would be my Y, and then the up and down is what we call our Z, and those are controlled with motors. So like here's the Z motors that twist and like make this whole thing go up and down. This has motors here and here that make it go left and right on the x-axis, and actually this whole print bed right here goes back and forth on these rails, and they have motors that control it. So some of them have like little print displays here, and you can use like an SD card. Mine are hooked directly up to laptops, so we don't even use the SD card. I have a laptop dedicated to them. But yeah, you can put your file in, and whenever you make a 3D model, you have to put it through like a slicer, is what we call it, or it's a program that breaks up the shape into a bunch of layers and then tells the machine what to do. It gives it G codes, what we call it. And we use this in machining as well, but it tells it the path to follow. And so you're creating these paths, all right? So you got your print bed. It's really important to know your print bed size. The printers that we use are 5 inches by 5 inches, though I do have a really large 3D printer, but we probably won't be using that as much. It's really for special projects. Okay, so your print bed right here, hot end, extruder, filament, display. It's pretty easy. I mean, that's the basics. There's a lot more to it than that, of course. So let's go into actually watching how this works. So I'm going to watch. This is a video by Sean Gano. It's a time-lapse photo of him making this little baby Groot. And so he actually does it in 2 parts. You're going to see him do the body first and the head. Okay. So you can see it's doing the first layer. And if you look at this, it actually goes really slow. I think people think 3D printing is really cool, but it actually takes hours and hours. So, like I have 4 3D printers in my class, and I have a laser cutter, and I kind of prefer the laser if I can make something out of the laser because it's so much faster. But you can see it going layer by layer, moving up higher and higher. This one, the bed moves as well. So he gets the neck, he stops, and now he's going to do the head. So there he makes the head. And he's going to chop that off somewhere and then put it in the design. And he's done. 3D printed objects tend to have these like little layers. You see these like lines right here. Okay. So one thing to watch here is where is it? Sorry. Right before, sorry. Okay, there we go. Make this full screen so you guys can see it a little clearer. Okay, right here. If you can see, Kayla, can you see this grid right here? Where you can tell it's not solid, right?
Yeah.
So this is what we call an infill. Let me show you this right here. Nope, this one. Okay. Oh, it's under this one. All right, so this is an infill. All right, so generally you don't want to print something at 100% infill unless you really need that strength or you're wanting it to be heavy or something like that. Believe it or not, most of the time, like a 70% infill, it feels just as tough as a 100%. It's really strong. So it really depends on what you're making. If you want to use an infill or go 100%, so you need to think about that. But one thing to consider about these infills, so here's 0%, you can see there's no grid. 5 pins really far apart, 10, 20. I think the one we generally use something about like this. It's a grid, we don't use the honey pattern. These patterns, they're for different reasons. If you want different kinds of strength, like if you want a strength along the outside or a certain direction, the honeycomb's really good for that. I mean, it just depends. Some of these are designed for saving filament. And so the reason why you want a pattern sometimes, and generally you don't just always go with 0%, is think about it like this. I meant to get some gum to chew to show you guys. Let me see if I've got something here. Okay. So imagine I'm chewing gum, right? So I'm chewing gum, and I put it out in my hands and I stretch it way out. Kayla, what do you think is going to happen if I'm holding it way out wide?
It's gonna get longer.
It's going to get longer. Unless, and for this sake, let's also pretend that it hasn't broken. So it's gonna, what's it gonna do? Is it gonna be like a string? Like, is it gonna be tight?
No, it's gonna be stretching.
And what's gonna happen in the middle?
It's gonna be stretching.
It's gonna get like thinner or something.
And
it's gonna get like thinner or something.
It's gonna make it droop down, right? Like it's gonna go down. Okay? So if I stretch out that piece of gum really far, it's gonna kind of sag down. It's not gonna stay straight across, right? Does that make sense to you? Or here, think about it this way. Let's say I choose that piece of gum and I spit it out and I pull it back just 1 inch. Okay? Do you think it's gonna sag very much in the middle? Droop down or sag?
If you chew it?
Yeah, 1 inch versus like a whole, like my whole arm span. Which one do you think is going to droop more?
Your whole arm span?
Yeah, right.
Your whole arm span?
The reason why we have this infill, because like if you try to stick that, basically imagine like hot glue right here and try to stretch it all the way across to this end over here on the 0% infill, it would sag down low, right? It needs something to kind of touch it. So if you do it here, it's not going to sag because it's going to have something that it hits every so often. Okay, so depending on the material you're using, you might need to use a higher infill just so you can like not have any sag in your design. Does that make sense? So it's kind of interesting thing to think about. And like some of these are, like I said, designed for strength. Like the honeycomb, some of these are designed for saving space. Like this one, it's more for saving material. It's just enough to not make it sag a lot, you know. So, kind of interesting stuff. All right, so let's move on to. Okay. Oh, not that one. There we are. Okay, oh, you have me off. So this is something that we 3D printed for a class. They're doing a competition where they demonstrated surgery and they weren't allowed to bring a live blade to class, so one of my students made this for that teacher to use. Okay, I'm going to go into Tinkercad and I'm going to create a new design. Okay. So, first off, when you 3D print, the size of your print bed is very important, right? So, I already told you guys that it was in inches and that the print bed is 5 inches by 5 inches. Okay? So, you can see each one of these grids represents a inch. So I'm going to take this and I'm going to make this, okay, 4 inches. All right? Then I'm going to click this. I'm going to hit the duplicate button up here. And, oh, actually, before I do that, I'm going to make this transparent. This will make it a little easier. So let's say this is the shape we're trying to make. I'm going to hit duplicate now. Okay? And I'm going to make this not transparent. So remember, this is additive manufacturing. You're adding a layer. So it prints the first layer, then the next layer, then the next. It's slowly building its way up. All right? So while you're thinking about how it prints, let's talk about some shapes. So I'm gonna take this, put this down. Okay. Delete that. Okay. I'm going to bring this up 1 inch. Take some of these guys. Paste it. And let's make this color all solid. We're going to make it one shape. Okay. So, Kayla, what do you think? What would you think would happen if I sent this to the 3D printer? Do you think it would print just fine, or do you think there'd be any issues?
I think it'd be an issue because it's too tall.
I think it'd be an issue because it's too tall.
The tall, kind of. Keep going. Let me see where you're going with that. So actually going straight up and down is not an issue. So like if I want to print this right here, even though it's taller, this isn't going to have an issue. So why do you think this one would have an issue when this one wouldn't?
Is it because how thick it is?
Is it because
Nope.
how
It
thick
has
it
to do
is?
with that gum stretching theory I talked to you about. Think about that.
It's too long?
Kind of.
It's too long?
So think about if I was to take like a piece of hot glue and try to go across this thing, what would happen?
It's not a solid.
It's not, so it's going to droop
It's
down,
not a
right?
solid.
It's going to create what we call like a bad print. So I'm going to show you a picture of one here. Like this right here. So whenever you can't go all the way across, it kind of starts messing up like this. Now this could have messed up for other reasons, but let's just pretend that's why. Where's my design? Okay, yeah, right here. Okay, so if you try to print from here to here, it won't work. Remember like the infill, when I was telling you like if this was hollow and tried to go straight across to make this top, it's going to sag down. So you need an infill. Well, one way to solve this is by adding supports, okay? And your slicer will generally automatically do this for you. So I'm going to make this. And you can, a lot of the times, those two, duplicate it. You don't have to worry about this. Like with 3D printers that you're going to be using in this class, you're not going to have to worry about the supports, but I still want you to try to use the least amount of support possible though, because it's expensive material. So, but do you see how if I was stringing that across, these supports would help keep that straight? Does that make sense? It wouldn't like wobble down. But there's a better way. Do you think there's a better way we can make this shape without losing any droopiness but also not having to use supports?
If you turned it on this side, it would still be drooping.
If you turned it on this side, it would still be drooping.
Let's do that.
But if
Turn
you
on
turned
its side. So where would it droop here?
It would droop like right here, because if you put the hot glue on there, it's gonna.
It would droop like right here, because
but you're not.
if you put the hot glue on there, it's gonna drip down still.
It's just building straight up.
Oh.
Do you see? Like where you had it the other way,
oh,
when it goes across here, it doesn't have anything to hold on to, so it's going to droop down. But this way, it's just building right on top of itself. And then another way to do it too, so let's go back, is I'm going to use the mirror function up here, like this. You see? So this is really the main thing I want you guys to take away from this video is understanding how to position your piece, okay? Because you don't always need, like, it can save a lot of time. It can get you a better print by just knowing the right way to position the piece. This is the way I think is the best way to do it for this particular shape. But just because you would get a nice flat top to it, whereas like the other area, you would, get a nice flat side. It just really depends what the piece is for. Okay, so let's go. I have another design here and another question. All right, yeah, this one right here. Okay, so this shape right here. Do you think I could 3D print this shape right here and not have any drooping? What do you think?
I feel like this is tricky.
Maybe. Just go with your gut.
I feel like
it's okay.
this is tricky.
You've not done this. You've never done this before, so there's really no reason to feel bad about being wrong. It's not like it's a, this is more just knowledge than it is. But I like letting you think about it.
I feel like if you're going straight up.
I feel like
kind of, and then kind of.
I mean, if you're going straight up, kind of, and then kind of not. But then if you're like going like side to side or however you say it,
I like the way you're thinking, and the answer is yes, you could 3D print this. And I want to show you, go back to this video. So let's go back to where, right there. Maybe. Oh, didn't want to pause it. Go back. Okay, so right here, look at this overhang. You see how it's printing just fine right there? It can go a little bit to the side. It just can't go way out. Does that make sense? So, just a little something I want you guys to know, because if you've never done this before, you don't know that. And a lot of mistakes with 3D printing are just because people position their pieces down wrong. And some of the slicing programs, they automatically put it the best way, but the one we use in this class doesn't. So it could print this just fine. All right, and this is probably the best way to print this piece. And the program might add in supports later. I mean, you never know. Okay, so like, something like this. If I was to make this shape right here, I've been doing this in my other classes, and when I don't align it in the middle, for some reason, it just really bothers me. So I'm going to align it, even though it's just an example. So let's say I make that. Go. So yeah, like it could 3D print this piece this way. Now it might make a little support piece in the middle. I don't know, it just kind of depends if the program thinks the material can do that or not, but it could print it like this, but do we want to? No, it's obviously going to be better to either print it upside down like this or at a 90-degree angle, right? Okay, does that make sense? So just think about that. So let me make sure we covered everything. We talked about what additive manufacturing is. Additive manufacturing is whenever you do layer by layer like this, and it can be metal, concrete. Like they have things that are like 3D printers that are giant and use concrete and can make buildings. It's pretty cool. They have metal ones that have like microwaves in that superheat the metal. Like I read that on the Navy aircraft carriers and like the big ships that they have out there, that instead of carrying a bunch of backup parts like they used to, they have these like $1 million metal 3D printers that can metal 3D print, use that additive manufacturing to make whatever part they need, and so they don't have to carry as many parts on hand. They have a bunch of parts that they can get away with just creating on the spot when they need them. All they gotta do is bring the material to make it. So pretty cool. We talked about infill, talked about the parts of a 3D printer, okay, and just kind of like how to position your piece. Those are really the most important things I want you guys to take away from. And some future things we're going to have is how to connect the pieces, how to get better with using measurement, and how to import other designs and where to find other 3D print designs and modify them. So that will be in the next part. So thank you, and I hope good luck with the quiz.